All right, so we'll kind of pick up where we left off, talking about instrumental variables. We'll probably get out of here a little earlier today. I'll add some things at the end I want to make sure I mention. Well, the final in-class quiz today. So the only other things left in this class, after we have this in-class quiz, I'll kind of create a new column on Canvas that shows you kind of the total in-class quiz points that you've had. So it's not currently being factored into your grade, it's just the number of points you're going to add into the end. We'll play around next week during the review classes with a hypothetical grade tool where you can kind of take those points, input them into an Excel file, and start to figure out, okay, what grade do I need in the final to get this grade in the class, to get this grade, etc. So the other two things that we currently have are the sixth and final problem set. So that's going to be related to panel data, which were the videos I posted before Thanksgiving, and as well as what we talked about this week, which is instrumental variables. So if you use the do files that I've put up kind of here for this IV and then also for the panel data, those should be very good templates for how to answer any of those questions. You know, in those files, I've got like comments and things, so that should kind of help you, even though it's a different data set, kind of know how to apply it to a different, set of data. Once you have that sixth problem set completed, that's the last thing. The other thing that you have is a sixth quiz, although I've tried to make this completely free points. So it currently looks like, I think the way that it uploaded, I don't have it set as a quiz, I have it set as a graded survey. So for whatever reason, Canvas treats this a little differently. It inputs it as a 0. So it might be impacting your grade right now. This is kind of like worst case scenario that you just don't do this sixth quiz. Then your quiz grade that you currently see on Canvas is what your final grade would be in the quiz category. However, if you look at this sixth quiz, it's all opinion-based questions, right? I kind of mentioned this Tuesday. This is all just ways for me to kind of hopefully improve this class, also see what worked good for you, what didn't. I've done this in previous semesters, so you've been the beneficiary of previous semesters answering this quiz. I know this ultimately won't impact you, but right, it'll impact kind of subsequent. So I've done this before, so kind of passing the favor along. But also, it's not just optional. I've tied points to it to make sure that all of you do it, right? This should be completely, it should be a very easy quiz. You should be able to earn all of the points possible on it. Although, why is it set? For some reason, this one's showing up as a 0. I'll make sure that it's kind of counting as 1. But it'll show up as a 0 in the grade book until you complete this quiz, in which case then it will update your grade, right? So as soon as you complete it, it'll update it to, essentially 20 out of 20 is the total points possible on this quiz. As long as you answer every question, you should get all 20 points. So as long as you do this quiz, it should only improve your quiz category grade in this class, okay? So those are the only other things we have left for the remainder of the semester, this week and next week. Get that sixth quiz, just get it out of the way early so you don't have to worry about it. You've got other finals to worry about next week as well. Completing that kind of final problem set, try to get on that as early as possible. So you can start thinking about studying for the final, which I pointed this out Tuesday as well, and I'll get them added to the homepage after class today. But these final exam, I have the practice final exam and the formula sheet that you'll have for the final already up on Canvas. I would start kind of going through that. You also have old quizzes, old quiz questions you can work through. You also have old practice problems. So once again, this sixth quiz, it's kind of just, it's not related to content. However, if I had asked you or kind of put together a quiz, I put some sample questions up. Here's the type of quiz questions I would have asked you, so you have some additional study materials from the panel data and instrumental variables topics as well, okay? So I'll probably reiterate all of this next week in class as we kind of start to study these things. I'll field questions from you guys from any of these materials that you have questions on, the quiz, practice problems, or that practice final. I want to make sure, you can ask all these questions and we feel very prepared going into that final exam, okay? Any other questions from me before we kind of jump into material here? Yeah.
You said that the final is cumulative, pertaining to everything this semester.
So it's cumulative in the sense that we've built on everything we did the first half. It's only going to be related to questions that we've covered or topics we've covered since the midterm. Yeah. Okay. So don't go back and study week 2, week 3, unless you're really having a hard time still with like p-values, right? But kind of I would just go over the material that we've covered since the last exam, which are all of these weeks where I actually put a name to it. So nonlinear relationships, interaction terms, data issues, panel data, instrumental variables. Yeah. And then as long as we're here, because I've gotten a question about it and I didn't want to do it from memory. In the syllabus, it's been up there the whole semester. The date for this final exam is going to be Thursday of final exam week. I don't pick and choose these dates and times. This is given all of your schedules and room availability. So I don't really have any flexibility over changing this, right? So we'll kind of meet that morning of the Thursday of exam week, 10:20 to 12:20. You should be in this room. 2 hours. Exam should be pretty similar in length to the midterm, maybe a little bit longer, but you should have a little bit more time per question. So time shouldn't be as much of an issue as it was on that midterm. Okay. Any other logistical questions for me before we jump back into material here today? We're good? Okay. All right. So we don't really have any new slides to kind of cover today. We've covered them all. We're just going to look at a different example in Stata, right? So we'll kind of start out doing a little bit of review of what we're doing with instrumental variables and the main takeaways that I want to make sure that we have down. So what we were talking about with instrumental variables is that we have some relationship that we want to estimate, right? The effect of X on Y. However, we have things like omitted variables, right? I might not have any other control variables I can add in here. I might have measurement error. I might have simultaneous causality. All of these things that we talked about that might impact or cause bias in this estimate, right? So how can I eliminate that bias? Well, we said we can use an instrumental variable approach, which using this instrument of Z, we had two criteria or two conditions that needed to be met for it to be a good or a valid, probably more technical way of saying it, instrument, right? The first was we needed our instrument to be endogenous to our X variable. So what that's really saying is we need the covariance of our X variable with this instrument to be something other than 0. So in other econ courses, probably even specifically macro, you talked about like things that are endogenous to your models, things that play a role, that matter, right? Things that have an effect on your X variable, okay? So that was our first criteria, and we'll, by the end of today's class, rehash some of the things that we can use statistically to verify that we do have this condition met. Our second condition was that it's going to be exogenous to our Y variable. Now, technically, and I might kind of, I'll probably touch back on this a little bit at the end of class with an example I use. But for now, the technical support for why our variable or instrument Z would be exogenous to Y is that the error term from our original regression that we were interested in, that error term is uncorrelated with our instrument. Now, I said for the sake of this class and what we're going to do, an easier way to think about this, and if you were to kind of give me the support, I would say this is the correct answer. Although, again, I'll mention in class how it does vary a little bit. But what this is really saying is that instrument correlated at all with your Y or dependent variable, right? You need it to not be correlated with that Y variable, or you need it to be exogenous. It's completely unrelated to that Y variable. Like I said, this is the kind of technical condition that it's not correlated with the error term from your regression. But for the sake of what we're going to do, and we can just think about it, is it correlated with that Y variable, right? And they're really saying very similar things. Any questions on this? So as a reminder, once these conditions are met, what was our instrumental variable approach? Well, we had a first stage and a second stage, so we had to run two regressions. The first regression we were going to run was we use our X variable as our dependent variable and try to predict that using different values. And this is kind of an error term. I'm just using U instead of epsilon to indicate that like it's a different error than our naive regression. we're going to use our instruments variable or values to predict, right? Once we have these coefficient estimates, we're going to predict our X values. Once we have those predictions, our second stage, right? We're going to actually try to estimate the original regression we were interested in. But instead of using the actual X values, we'll use our predicted X values. Okay? So you can kind of see here, this is why we needed Z to not be correlated with the error term here, so that when we're using these predictions, essentially the intuition behind what we're doing is in this first stage, we're pulling out any impact that X is having on Y that's coming from changes in our instrument. So we're kind of pulling that effect out. So by pulling that effect out, when we use those predicted X values, we've pulled out the effect of this instrument. We're only getting the effect of the actual changes in X, not the part of the effects that's also coming from the fact that this instrument's values are changing as well. So I won't quiz you in how to say it, but that's essentially the intuition behind what we're doing. So once we run this second stage, using our predicted X values from that first stage regression, here we're now going to end up with an unbiased estimate of beta 1. So this procedure will allow us to go from having a biased estimate to an unbiased estimate as long as these two criteria are met from our instrument, right? That it's endogenous to our X variable and exogenous to our Y variable. Okay. Any questions on this? Once again, kind of a recap or a summary of just in general what we were doing. I said I'd bring in a couple examples. So before we dive into the stata, there we go. I'll give you a couple examples. I looked at it, so I had some papers. I could kind of remember some of them. I couldn't remember others. So I looked some up. I'll save some of them for the end, but I'll introduce a couple of them now, just so we can actually think about what this looks like, not with just X, Y, and Z, right? So the first one I have is, there was this paper, it's kind of old now, where they were trying to predict birth weights, and they had cigarette use of the mother while pregnant, right? So birth weights are generally higher for healthier babies. So we can start to think about what's maybe an instrument I could use, because I know that what's likely the effect of cigarette use on birth weights? If birth weights are higher when babies are healthier, someone who uses more cigarettes while pregnant, the birth weights are likely going to be lower. However, someone who's smoking while they're pregnant is likely doing a lot of other things while they're pregnant that's not good for the baby, right? So we have a lot of omitted variables that are going to cause a bias in that estimate. So I've got to think of a good instrument here. And these researchers thought, okay, what if we used the fact that across states, cigarette taxes vary, right? So we have variation in cigarette taxes across these states. Well, let's think about our two criteria. Would this instrument, cigarette taxes, be endogenous to X? So we would say, is the covariance of cigarette use with cigarette taxes, if it's endogenous, that covariance would be something other than 0. I mean, hopefully as econ majors or this far, and if you're taking an econ this high up, if I have higher cigarette taxes, what should happen to cigarette use? Lower, right? Taxes should decrease our supply curve, reduce quantity. So it's, hopefully, if, anything in your introductory micro courses are true, we know that there's going to be a relationship here, right? We know that covariance is going to be something other than 0. So that one's pretty easy, right? In this example. Excuse me. The second criteria we had was, is it exogenous to Y? So is the covariance of birth weight here with cigarette taxes, is that equal to 0? Now, the researchers and I personally can't come up with a way where if the government all of a sudden changes its cigarette taxes, what impact should that have on birth weights? Remember, it's direct impacts on birth weights, not through any of our X variables. So not through the fact that it might change cigarette use of the mother, but just having a different cigarette tax, I can't think of any story where that's gonna all of a sudden impact birth weights. They should be unrelated, right? Now, maybe there's a really convoluted story where if you don't have other controls, I don't know, cigarette taxes are an indicator of that the government might be increasing prices of other things, and so you start, making different, you start not spending as much money on food, and so you're not having as high quality food, and maybe that leads to lower birth. That's a pretty convoluted story, and probably, not likely the case. Now, even if that's the case, if you think that this instrument, cigarette taxes, would be influencing things like how much money are pregnant women spending on their food, as long as you have a control for that, you're thinking about just how would cigarette taxes impact birth weights through anything other than the controls you have in your original first stage regression. So once again, they do control for some of these other things. I can't, the researchers, and I can't think of a story where cigarette taxes just initially are going to impact birth weights. Now, they will impact it through their impacts on cigarette use, but we're capturing that in our first stage. So this would be a good example of a pretty valid instrument, right? And they go through kind of the support as to why, and we'll look at and stated here some other examples and say, how do we kind of maybe test to see whether or not these conditions are true? Okay. Any questions on that before we keep moving here? So the other one I tried to think of, this is not a paper. I'll use other ones from papers here in a second, but I thought it was somewhat relevant to this class. We can maybe think about if I have the data. What if I wanted to predict what your exam score was from the number of hours you studied before the final? Okay. So the problem is people who end up studying more, right? Maybe could be the fact that, well, actually people who had a higher ability maybe didn't need to study as much, right? So the people who actually are studying more didn't have a good grasp of material. It might actually look like hours studied decreases exam scores. I've got these omitted variable biases I need to eliminate. So what's an instrument I could use? What if I had data on whether or not the individual was sick the week prior to the exam? Well, I can think about, would this be a good instrument? So I'm going to make the added assumption here that you were sick the week prior, but not the week of the exam, right? Just that week when you could have been studying. When you actually go to take the exam, you have no lasting like cognitive effects, right? You're clear-minded, you're back to 100% healthy. So what our first condition, is this instrument endogenous to our X variable? So is the covariance of being sick that week prior with hours studied, is that something other than 0? Well, if you're sick the week before the exam, do you think that likely has an impact on the number of hours you can study? Yeah, right? This is, I think, hopefully an easy one to think about. Yeah, there's definitely going to be a relationship between these two variables. Is our second condition met? So is that exogenous to Y? So is the covariance of your exam score with were you sick the week prior, is that equal to 0? Now, here's where it gets a little tricky. Remember, this exogenous to Y is, would this have any impact on your exam scores that don't operate through your X variable? So yes, the fact that you were sick the week prior might impact your exam scores because you could study less, but we're just thinking about the effect of being sick the week prior that isn't operating through our study. So just being sick the week prior, as long as you're healthy once you sit down to take the exam, should that have any impact on your exam score that isn't operating through your hours studied? No, right? I mean, I can't think of what the explanation would be there. Now, how could this condition break down? Let's say that this indicator for whether or not you were sick the week prior, let's say you aren't 100% recovered, so that when you go to sit down and take the exam, you're likely that your kind of mental faculties are still a little bit less than 100%. Well, then maybe being sick that week prior, that covariance with your exam score wouldn't be equal to 0, right? So this might not be a perfect instrument if I don't add in that assumption that you were only sick that week prior. There's no lasting effects when you actually take the exam. if there are any lasting effects where you still have this decrease in mental faculties, it wouldn't meet that criteria. That covariance between your instrument and Y variable would likely be something other than 0. Any questions or comments or thoughts on either of these examples here? All right, so let's work through some stata stuff, and then I'll come back at the end and do 2 additional examples where I can kind of make some points that I didn't make here. So we're going to jump back into that IV do file class file. We're all the way down here where we're looking at this second example. So I'm going to run this line of code. This just opens up a free data set, that BQ's command. There's some wage data set that exists in Stata that you can use for free. Okay? So I'm going to open that up. I've got things like, I think it's monthly, or this might be weekly wages, hours worked, the IQ, all of these different variables. Okay? So I'm going to start out with a very naive regression where I may be interested in what's the impact of another year of education on this individual's wage. Okay? So I'm going to run this regression and see for every additional year of education, the weekly wage goes up by what, $72. This is an old data set. It's for like, what I remember right, I don't think it was just specifically the automotive industry, but primarily that. So we've got kind of like some 70s data. So these numbers are going to be a little bit smaller. But this coefficient, even though we have additional controls here, it's likely that the number of years of education are going to be correlated with other things that also impact our wages, right? So we've got a lot of omitted variable bias here. So even though we see this coefficient, this is going to be our bias coefficient, right? We've got an omitted variable bias that's caked into that. So I was trying to think of a good instrument that exists from this data. Now, my original thought was, what if I look at parental education? So if you're working a job, they should be paying you for the work you're doing, right? For your own underlying ability. If you go, I don't know, even if you think about going like working for, I don't know, Chipotle or something, are they going to pay you a higher wage if your parents have a higher education? They don't care. It doesn't impact them at all. So parental education really shouldn't have any direct impact on the wages of an individual. So it would likely be that if I could use parental education, it would be exogenous to this wage variable. Now, however, if your parents have a higher level of education, if I'm interested in the effect of your education on your predicted wages, if your parents have a higher education, what's more likely to be true about your own education? It's likely to be higher. So there, the instrument of parental education, it's exogenous to our Y variable, but it would be endogenous to our X variable that we were interested in the effect of, right? Your own individual education. So on its face, I would think this is likely a good instrument, right? Just intuitively. Now we'll have some statistical support here in a second for how we can identify are these criteria met? But for now, we'll just assume like intuitively, we think of this as a good instrument. Now, I didn't have a parental education variable here. Technically, you could create it. Like I've got mother's and father's education. So I could say, create parental education equal to 1 if father's or mother's education. We'll just use father's education here just to make it kind of simple. It's a variable that already exists in the data set. So we'll kind of use that as our like proxy for parental education. Okay. So we talked last class, there's this nice built-in kind of easy, I don't know, shortcut, I guess, command, where instead of like using the regress command, if I use IV regress, that stands for instrumental variable, that tells state, okay, run an instrumental variable regression, and I want you to give me the first stage output as well, right? So I want the first and second stage output. My Y variable, and we always have to use 2 SLS, that's all we're going to use in this class. There's other types of instrumental variables or other types of commands you can use with IV regress. We're not going to do anything with them. We're only going to look at this 2-stage least squares. That's all I've told you about, right? Running those 2 different stages. Here's my Y variable, which is wage. The X variable I was interested in, which is the individual's education. And I wanted to instrument individual education with the parent's education, or in this case, father's education. Now, I also can include still additional controls here on the right-hand side. So I included controls for their experience, age, and whether or not they were married. So if I go ahead and run that line of code, I'll get my first stage results here. So this is where it treats education as my Y variable and uses that instrument of father's education. It then uses predictions from my first stage, oops, down here. So this isn't using my actual education values. It's using the predicted education values from that first stage. So I'll show you a way that's a little bit less black boxy in a second that really makes this obvious. But this is using our predicted education values, or X variable, or predicted X values. So here I can see now, this should be, if I had a good instrument, it met those two criteria, it should eliminate a lot of that bias that existed in my naive regressions coefficient estimate. So instead of 72, I'm now getting what? 142, so almost twice as large, right? So here we can kind of see a pretty good example of like it can greatly change your coefficient estimates because it's eliminating all of the bias that might exist from omitted variables, measurement error, simultaneous causality. What else do I want to say here before we keep? So that's kind of my shortcut, right? I'll kind of break this down how you could do this step by step if you wanted to. So you could run the first stage yourself, right? So for us, our X variable we're interested in was education. So in our first stage, that now becomes our dependent variable. We're then going to use the instrument of parental or father's education, run that first stage regression, and then the way that we can come up with predicted values in Stata was using that predict command and then comma XB. So XB, like B is our betas, our coefficients, X are the different X values. So we're going to create this new variable, which is education predictions, or I called it edu predict, right? This is going to be my predicted X values or my predicted education values for every observation. So I'll go ahead, run that. I can kind of see that in the data. Okay, I've created this predicted level of education here. Right? So I'll reduce or decrease that. Actually, I think I technically, just so we're getting accurate results, I should be running these two lines of code at the same time. So there we go. So we've got our predicted education values. Then in my second stage, I'm going to try to predict wages now, the original thing I was interested in, not with the actual education values, but the predicted education values from my first stage. This is all the IV regress command is doing, right? So I'll run this second stage regression. Notice, here's my first stage results. So the instrument's coefficient was 0.214. If I go back up to that IV regress command, my first stage results, that coefficient, 0.214, same exact value, just different way of doing the same thing. Second stage results from that IV regress command, 142. Second stage results, if I do this kind of manually, 142. I'm going to get the exact same results if I use that shortcut or if I kind of break this down into steps on my own. Now, which is better? It's the same results. It doesn't really matter which way you do it. You know, the first way saves you a little bit of time and a little bit of space in your do file is really the only difference. Okay. Any questions over anything there before we keep moving? Yeah.
I know you mentioned it last class, the two-stage linear, the 2SLS.
Mm-hmm.
The benefit of that is that it takes away, you said bias, what were the other two? The reason we're using the two-stage 2SLS.
Yeah.
Is that it takes away all the other
So if I have any bias that exists because of omitted variables, so I don't have data here on I think, yeah, I don't have the region, I guess I have South, but didn't use it. I didn't use what region of the country does the person live in, what industry does the person work in, what state did they live, the education system is different in different states. There's a lot of omitted variables that are likely causing bias in my estimate. By using this two-stage least squares regression, I can eliminate the omitted variable bias. I also have measurement error, right? I'm likely not getting completely accurate wage values, right? This is self-reported data. For sure, my wages are going to be a little bit off. No one knows, it's going to report exactly what their pay stub said. So I'm going to have measurement error, omitted variable, and then we could even have things like simultaneous causality. And this isn't really a good example of that. Although it kind of could be, because if I have a higher level of education, right, and I can earn higher wages, maybe it makes it more likely I can go back and get more years of education and then a higher weight, right? So there might be some kind of a simultaneous causality here. By using this instrumental variable approach, I can eliminate all of that bias. Yep, is that what you're getting at?
So is the difference between the 142 and like I think the 80, is that the size of the bias, the difference between the two?
You can think about that's the bias that we were able to eliminate using the instrument.
Okay.
Yep. Any other questions on that? So, what else do I want to say here? A couple things that we didn't talk about yet. Is what are some statistics I can use that tell me whether or not my first criteria is met? Okay, so is my instrument of father's education endogenous to the individual's own education? Well, two things I mentioned last class, and one of them we'll kind of go through in our second example, but for now I'll just kind of hammer the first two again. So if I want to know, is this instrument endogenous, I'll look at the first stage, and there's two things that tell me whether or not my instrument was correlated or was endogenous to that X variable. So what was, remember two of the things we talked about last class. The first thing I can look at is simply, I've got my instrument, and I know the coefficient, I could look to see if it is statistically significant. It is. So that tells me there is some statistically significant relationship between this instrument and my X variable. That's example or evidence one. Right? Second piece of evidence that this is endogenous, this instrument, is I can look at, we said, the F statistic from my first stage. And that F statistic, as long as it is greater than, remember what value I said is a good benchmark? 10, right? So regardless of sample size, if we can get an F statistic greater than 10, it's generally probably going to be evidence that we have an instrument that is endogenous to X. So those are our first two criteria, right? Those are our first 2 points of evidence. So I shouldn't say criteria. Our first two pieces of evidence that our first criteria for a good valid instrument is met. Okay? Now we'll talk about a third one in our second example here in a second, but for now, those are our first two that we've talked about. Okay? Any questions on that? Okay, so we're kind of looking at statistical significance of the instrument from first stage, and then is the F stat greater than 10 from our first stage results. Okay. So another thing that we talked about last class that could pop up on the final, you might see this like in the practice problems, is because I'm not having you use data on the exam, I might give you some output and then ask you the following question, right? So I said last class that what will be true if we have a simple regression without any added controls. The math is a little bit harder if we add in controls, but so for the sake of this example, we'll just assume we're not using any. That's as far as I'd push you. We said if we use this instrument Z, our second stage coefficient that we see that's unbiased will simply be the covariance of Y with our instrument relative to the covariance of our X variable in that instrument. Okay? So this will be one of the formulas you have on that formula sheet for the final. I might do something like the following, and I'll come back to that here in a second. So if you were writing it down, you can write it down again. I might, so let's say I run these two commands where I'm looking at the correlation between wage, my Y variable in the instrument of father's education, the correlation of education and father's, so X variable and the instrument. I then put the covariance. So this is going to give me the covariance of my Y variable with my instrument and my X variable with my instrument. So I might give you this output where you can identify the covariances of the instrument with your y variable and the instrument with your x variable. If I then ask you what is the unbiased coefficient estimate from that two-stage least squares regression, it should simply be the covariance of the y variable with your instrument divided by the covariance of your x variable with your instrument. Maybe a good way of remembering the order, like I said, you'll have the formula sheet, but it's kind of like calculating a slope. Change in y over change in x, the y goes on top, x goes on the bottom. So here I get 100.67. That should be the exact same result I see if I were to use this instrumental variables approach. But I said it only holds if I don't add any additional controls in there, right? So I kind of eliminated these controls we were using before, just to kind of prove the point that if I run this, hopefully for my second stage, the coefficient I see is 100.67. It's a little bit off. I was rounding these covariances to the third decimal. That's where that comes from, right? It will be the exact value if I were to keep it out to, 7, 8 decimals. Okay. So on the exam, I might do something like that where I give you those covariance matrices, you choose those covariances, take the ratio of the two, and you can tell me what that unbiased estimate would be. Okay. Any questions on that before we keep moving here? Yeah.
So why is that different from the 142 we got before?
Yeah, so what I did here is I didn't include these additional control variables. So what ends up happening when I find covariances, I would then need to subtract out the covariance of my x and y variable with each one of those controls. So the math just becomes a little bit more difficult than simply the ratio. I would have to take the ratio and then eliminate all the covariances of the x and y variable with all of my other additional controls. So the math would become harder. I would never ask you to kind of push it that, but that's why it does look a little different. Any other questions on this one before we keep moving? Okay. All right. So that should be pretty good. So I'll go through this next example a little bit quicker because I want to save a little bit of time to do some what I think are more interesting examples. Also, I'm not going to make you do this. You've already kind of seen me do this and state a decent amount. But I had this second example where I was going to look at the same data set. But now I'm going to be interested in the effect of the individual's IQ on their predicted wage. Okay. So I could run the naive regression. And I included those same 3 controls that we were using before. So it looks like IQ has a pretty positive effect on wages. That's not surprising. But I likely have a lot of omitted variables, right? Also, there's some pretty good studies out there. Like you can have the same individual take an IQ test 10 times and they never get the exact same score, right? So you know that if you just make them take it once, you're actually not getting a perfect measure of their IQ. You have some measurement error existing. So we might have measurement error. We likely have omitted variable bias. So what can we do? We can try to find a valid instrument, right? So I had this data, or I had this variable in here, and it's this really goofy test, which is like knowledge of the working world. And it's not, IQ is really trying to measure your intellectual ability. This knowledge of the working world, a lot of automotive companies and things used it back in the day for people that maybe didn't have college educations and tried, it's supposed to be some measure of aptitude of how you just manage difficult tasks. Right? So it's some measure of aptitude, but not necessarily intellectual ability, right? So there's some evidence that it's not a really good predictor of wage. So there's some research out there that all these companies were using it, but it wasn't really the best predictor of kind of what their skill level would be at these actual jobs. However, what they did find is it did have some correlation with their underlying intellectual ability. So if I'm using this KWW, this is their performance on this knowledge of the working world test. So this test, if it does have some correlation with IQ, it would be endogenous to my X variable. But if it ultimately was found that it really didn't impact, what companies were willing to pay these workers, it doesn't have any impact on wages, it would be exogenous to my Y variable. We'll just assume that for a second, that it is a valid and a good instrument, okay? We'll talk about why maybe it's not here in a little bit, but let's assume for now it is a good instrument, okay? Well, I could do the same thing I was doing before. I could manually go through, run my first stage, where now I use my X variable as my dependent variable, and then predict those X values, right? So run my first stage regression, create this new variable, which is the predicted values of X. So I'm going to do that. Now, from this first stage right away, what two pieces of evidence do I have that this might meet my first criteria, that this variable KWW, this knowledge of the working world test, is endogenous to IQ, my X variable? So the first thing I can look at, so if this is my instrument, is it endogenous to X, IQ? I can look at what? Is it statistically significant? P-value 0, yes. So I have pretty strong evidence here that this instrument, this knowledge of the working world test, is correlated with IQ. Okay, so that's evidence point 1. Second piece of evidence, I can look at the F statistic from this first stage. It's 73, not quite as high as the previous regression we had, but still well above 10. So here I've still got two pieces of evidence that it meets the first criteria. Okay. So we're going to go down then, run this regression. Excuse me. I skipped. We were right here. I skipped down too far. Here we go. We were right here. I'm going to run my second stage, where I then try to predict wages using these predicted IQ values. Okay. So I'm going to go ahead and run that. And what I see is from my naive regression, where I was getting a coefficient of 8.4, by using this instrument, the coefficient that's unbiased is about 16. So once again, almost twice as large. Right? So there was a pretty considerable bias I eliminated by using this instrument. Any questions here before we keep moving? So shouldn't be anything too crazy. Now, the one thing we haven't talked about, and I could just be complete, I could use that shortcut. So use wage, my independent variable I was interested in was IQ, instrument it with this KWW test. I get the exact same value, right? 16 point, where is it at? 0.78, right? Does the exact same thing. Can do it by hand, or kind of manually, or just one line of code. Now, one thing that we had is a third point of evidence that I kind of hurried through at the end of last class, but I'll kind of rehash it here today, is this Durbin-Wu-Hausman test, okay? So what we're going to do, and here W is just pointing out, we can add in additional controls, right? So like age, experience, whether or not they were married, these controls we were using, we can use all of those. And I had a little typo here because I was copy pasting. So what we're going to do is we're still going to run our first stage regression. So if I'm thinking about here, our example, the original regression we had was wage, and we wanted to know the impact of IQ. Right? So now we're going to use this instrument, which was this knowledge of the working world test. Okay? So the error term from our first stage, we're going to call U. So we're going to run our first stage regression. Instead of predicting our X values now, the test for endogeneity, what we're going to do is predict our error terms, or come up with what the difference is between our actual X values and our predicted X values, right, from this first stage result. So I'll walk through the procedure and I'll try to give some intuition behind what this is doing. But to do this Durbin-Wu-Hausman test, we'll kind of run that first stage like we typically would for instrumental variable regression. But then to see whether or not this instrument was endogenous to X, we'll use the actual X values now. So we aren't doing instrumental variables here. This is a test for endogeneity. We'll have our additional controls, and we're also going to be including our predicted errors now. If we can reject the null for the coefficient on our predicted errors, what we're saying is those errors from our first stage regression are having an impact on wages, that's gonna tell us that our instrument has some endogeneity to our X variable. So once we use this method where we put the predicted errors into our original regression, if we can reject the coefficient on those predicted errors, we're saying that that instrument is endogenous to our X variable. So the reason behind why, kind of what we're doing here, to give it a little more intuition. When we're coming up with these predicted X values, because we're not really including the instrument in this regression, essentially what these errors are picking up is the impact that our instrument was having on the X variable that was then impacting the Y variable. So it's telling us whether or not that relationship between our instrument and X was actually then causing effects on Y. So if it is causing effects on Y, then that was a good instrument. It was changing the values of X enough that it ultimately then impacted Y. So that's kind of the intuition behind what this is doing, and why if we can, find statistical significance of that coefficient on our error term from the first stage, that's really telling us that there is a significant relationship between our instrument and the X variable. That in fact, that instrument is also endogenous. It would be our third point of evidence, right? So what does this look like in practice? Well, we've got our first stage regression. We're just looking at IQ and that knowledge of the working world test. I'm then going to use my predict command to not come up with predicted values of IQ, but to come up with the predicted residuals or the predicted errors from that first stage regression. So I'm going to go ahead and do that, right? Notice it's the same kind of values, same F statistic values. It's still my first stage results. It's just now what I'm saving in here for this variable is the predicted error terms, not the predicted values for X. I'll then run this second regression where I now am using the actual X values, but putting in the predicted errors from that first stage. So if I do this, I see that the coefficient on that predicted error term is statistically significant. So this is my third point of evidence that that instrument is endogenous to X, that instrument of that knowledge of the working world test is endogenous to IQ. So I have 3 points of evidence that my first criteria is met. Okay. Any questions on that before we keep on moving here? Okay. So, excuse me. Sure. Okay. Sorry, I'm like making sure that my wife's okay. So we have 3 points of evidence for endogeneity. Now, to prove whether or not our instrument is exogenous, we're going to kind of punt on those issues for this class. It would take a little bit more to dive into them. They're probably something you would get like in the next econometrics class that you would take. Although a decent way to test this, can anyone think of a way we could see, is this knowledge of the working world test, is it exogenous to wages? Well, what could I do? If I include that instrument into my regression, if it is exogenous, what should the coefficient be? 0. So I could do something like, and I'll include as many controls as I can here, just a bunch of different stuff. Well, okay, I've got that it's statistically significant here, so maybe that wasn't a good instrument, right? It met the first criteria, and like 3 points of evidence we had that it met that criteria. But is it exogenous to Y? That's a little bit shaky, right? We have evidence here it probably isn't, right? So there's really better ways of identifying that we're not going to talk about. But just to kind of give some idea, like broader picture, we would actually, the next step would be we not only test for the endogeneity to X, we test for that instrument's exogeneity to Y. And to be completely honest, we're never going to have all the controls we want. So even when we run this regression, this coefficient could be having bias in it as well, because we haven't instrumented for it. We haven't done anything. So a lot of the times when it comes to that second criteria, you'll really see it's just arguments. You just take the 2 variables and you try to use intuition behind what those variables are do you think there's an actual relationship between them? And I'll give you a couple examples of what that would look like here in a second. and what you could expect in the final and how the answer can sometimes be it depends. For the sake of like that Durbin housing, let me test on that before I kind of go back to showing you a couple more examples and relating it to what we've talked about already. Okay with that? Okay, so I'll give you what I think is a good one to where we start to see maybe the pitfalls of instruments, right? It's very difficult to find a good instrument. So my third example for the class is going to be, there's this paper, oh, sorry, not life expectancy. They had like self-reported life satisfaction. And this was like for teenage kids. And they were looking at sports participation and seeing whether or not that actually led to higher levels of self-reported satisfaction. Well, I just said something that would make a naive regression we should be concerned about something. If it's self-reported life satisfaction, what do I likely have? Bias because of? I could have omitted variable bias, but if I'm self-reporting something, it's likely there is measurement error, right? So they're like, well, we know that this is going to be a pretty biased estimate. How can we get an unbiased estimate? So their idea for an instrument, and they called it the number of sports facilities in that city. And I think they did it at the county level as well. Now, when I say sports facilities, they were counting things like a YMCA, things that would give kids opportunities to be a part of any sport, right? So we can think about, okay, our conditions. Would this be endogenous to our X variable of sports participation? So if I'm thinking about the covariance between sports participation and kind of the number of sporting facilities in the town or in the county that they live in, well, we would think that that likely isn't something other than zero, right? There's more facilities, more opportunities. It's more likely that the individual, that the teenager is involved in some sporting activity, right? So it's likely that it meets the first criteria. Now the authors argue, and they went through basically the three things that we just talked about. They did the first stage, looked at the F-stat, looked at the statistical significance of the instrument, did the Durbin-Hausman test, and they found evidence that there is some endogeneity of this number of facilities to this X variable sports participation. Great. Now the second criteria, we need it to be exogenous to Y. So what that's saying is this life satisfaction, or thinking about like as happiness of these teenagers. If there's more facilities, sporting facilities in their county or city, will that have some impact just directly on their life satisfaction? Well, it might have impacts through the fact that they're more likely to be involved in sports, but does it have an impact that's not operating through that? The authors argue, no, right? There's not, right? Their intuition behind, well, how would having a YMCA, other than the fact that it might allow me more opportunities, as long as I can control for those other opportunities that, I'm more likely to be involved in sports, I'm more likely to maybe involved in after-school activities. It shouldn't just directly have an impact if someone builds a facility in my city that I am all of a sudden have higher life satisfaction. Right? Now, this is where I won't push you quite this far in this class. So this is as far as I would push you. As long as you give me an explanation that you believe that the correlation between those two things is zero and that it meets the second criteria, correct answer. If you tell me that the number of facilities in my area, like it makes it seem like I'm in a bigger city and just that gives me more license, then you tell me that it's not equal to zero and you say that it doesn't meet the that would be correct as well. So on the exam, if I asked you something about are the criteria met, you can give me an explanation. There might be multiple criteria. As long as you justify correctly, I would give you points for either one. Now, if you tell me it is exogenous, and then you tell me it's because the covariance is not equal to zero, well, that's not right, right? So there is a correct answer, but there might be multiple correct answers, right? Now, here's where the next level, so I'm starting to get a couple questions for some of you thinking about taking courses past this. So things I think 471 is the next level. You're graduating, you're not too concerned, but if you're thinking about working in a field we're going to be using some of this stuff, this becomes important. So I said for this class, all I'll expect you to know is give me support for exogenous to y of is the covariance of my y variable and my instrument equal to 0. I said technically it is the error term from my original naive regression, is that covariance with the number of facilities equal to 0. So what that means is what's in my error term. If I were to use no other controls other than sports participation, what's included in that error term? The number of facilities that maybe provide me art opportunities, the average income of that county, in which case, having a higher number of sports facilities, what do you think is likely true about those counties or cities in terms of the average income? Higher, in which case that error term is going to be correlated with the number of facilities. Now, if I can control for the average income in my first and second stage regressions, well, then I don't have to worry about those being in the error term anymore. So technically, I said for this class, we can just think about it being correlated with y. It's really, is it correlated with y through anything other than all of these controls that I've included, right? So the fact that it's correlated with the error term, I can reduce the likelihood it's correlated with the error term if I can include more controls in my first and second stage regression. Okay? But to be technical, this is why I like this paper. I read it because I was trying to find some interesting examples. The controls they had, they didn't have like average income. They didn't have like the number. Like I said, to me, if you have more sports facilities, you're likely to have more boys and girls clubs, opportunities for other after school activities. They didn't have any of those controls. I would highly doubt that the second criteria was actually met there with that instrument. So anytime you see papers or studies where they start to talk about their instruments, sometimes just the intuition, right? You can kind of think about whether or not that truly would be exogenous. Any questions on that before we kind of keep moving? I got one more example here for us. All right. So how many of you as good, how many of you are econ majors? Should be like almost everyone, or good enough. How many of you like good econ majors have ever read the book Freakonomics? Only a few. It's a pretty interesting book. There's been some criticism, some backlash of it, but it still kind of holds up, right? So one of the examples that they used there, so our fourth example. Oh, I want to get this right. So this was, they were looking at grade level or like elementary school performance on these standardized tests. And one thing that schools and states are always very interested in, and actually I would argue we could be interested in it for college at the college level as well, is what's the impact of class size on test performance, right? Now, test performance is really just a measure of how much are you learning, right? So ultimately, I would want to use like my exam scores and say, if I have smaller classes, do I tend to see that they're higher or lower, right? So the problem is, if I'm thinking about test performance, what types of parents are more likely to be able to afford smaller class sizes? Wealthier parents that have opportunities to other things that might also impact test performance, right? So there's a lot of omitted variables that lead to, it's not just like your class size is truly completely random, because parents can move to different locations where they know there's school districts that have smaller class sizes. They can go to charter schools, they can go. So I know that class size isn't truly going to be completely random, and it's likely correlated with a lot of these important omitted variables I don't have information on, parental income, maybe even just the different counties even have different amounts of state level funding, right? Based on the free and reduced lunch, things like that. So I likely have some bias that's going on here. So in the book, they think of this, you guys have read it. Do you remember what they use as an instrument? Okay, so this was, they use the student's birth month, right? Now, some people do plan out or to try to have their child born at a certain time of year. On average, most births are a lot more random, or it's likely, I don't think as many parents are making their decision of when they want their child born in terms of like when they're going to start school, right? So if we think of birth month being somewhat or pretty close to random, well, what's true about people who were born, say, in July. Well, they're either gonna enter the, school as the youngest or as the oldest in their class, right? Depending on kind of where the cutoff is in that state for the age at which you can enroll. So let's say, for example, that the state says, if you were born before August 1st, you can't enroll, right? You have to be whatever, 5 to enroll in kindergarten. You have to be 5 as of August 1st. Well, this is going to mean that someone born in July 31st, as opposed to August 1st, they're going to be in complete start school at different levels, right? So they look at the kind of average birth month kind of in these different areas, and that's going to then impact the class size because there's just going to be more available students to be able to enter school at that time. So this is all like county level data. Okay? So their idea was, okay, is our first criteria met? Is this instrument endogenous to X? So is the covariance of class size impacted by kind of the average birth month or what the kind of average birth month was in this county? Well, if there are state level laws that don't allow these students to enroll if they're not born before a certain date, for sure this is going to be an exogenous instrument, right? It's just by the letter of the law, it has to be, right? It's unless schools are, doing some shady stuff and allowing these students to enroll. However, and they could test this. They were able to look at those 3 criteria we've talked about: F statistic over 10 from the first stage, statistical significance of the instrument, run a Durbin-Wu-Hausman test, and they could see that this is in fact, this criteria was upheld. Now, the second criteria, is it exogenous to Y? So remember, this was where is test performance directly impacted to birth month, other than that it impacts what class size I'm entering into? Well, as long as we're controlling for things like age of when they started, this is gonna this is like the average in the counties. Remember, what we're really interested in is the covariance with the Y variable equal to 0, but is the covariance of the error term, right? So they can control for still things like the average age in these different counties. They can control for all this. So as long as that birth month is not correlated with anything other or anything else that's in the error term, this second criteria would be met. Right? Now, I forget what it was. So someone came out with an additional data set that basically broke down this second criteria and said it actually wasn't upheld. And if I remember right, I looked up the original thing. I didn't look up what the new critique was. I think what they said was, although you would think birth months are pretty random, that if you actually look at counties that have higher levels of education, which was not a control that they used in their regressions, that they tend to be correlated with also having birth months that are like right on the cutoff, so that their kids were typically starting school at like the oldest possible age, right? So they weren't starting school at 5 years and 1 day, they were starting school at 5 years and 364 days, right? So they were always kind of and if you're the older kid in your class, what are you more likely to be? Well, IQ is, in terms of when you're, getting older, it's kind of increasing, right? Or your intellectual abilities are increasing with age, regardless of whether or not you're attending school or any of these other things. And so because they didn't have that control, birth month was actually correlated with the error term, and their results weren't completely unbiased, right? So it gets really hard to meet this second criteria. But generally, so that's why we don't like to use things that still involve some individual decision making, things that are going to be a little bit more fail safe. Where is it at? It was like the first example, government policy decisions. Those are a lot more likely to not fail that second criteria, right? I don't know. So hopefully somewhat interesting examples, but also just rehashing and thinking about what we're doing here with instrumental variables.
I have a question. So I'm still thinking about like how birth month directly increase or decrease the class size.
So this was because it was at the county level. They were looking at like average birth month. So if a county just happened to have a higher number of births in July, that ultimately led to there being smaller classes entering that school in that particular year. So it was, you might think that effect is minimal, but it was still statistically significant. We don't need the effect to be large. We just need it to be statistically, so I'm not saying the covariance has to be greater than a certain amount. We're just saying that it has to be statistically significant and statistically significantly different from 0. Yep. Yeah, I would agree. And this is why like Freakonomics was kind of like a thing. They're trying to like come up with these like really novel uses. This might be a bit of a stretch. This was probably a little more of a stretch than this paper, which is like 40 years old and no one's poked holes in it yet. Right. So yeah, we can once again with any instrument, we should always be a lot of the times with instruments, you will have economists that will literally argue back and forth that it's valid or it's not. There often isn't like a perfect consensus. Yeah. Okay. Any other questions on anything that we talked about or? Okay, so I kind of told you we get out here a little bit early, but I have 2 more things that I want to show you. So the first, if you're interested, and I will put this up in a announcement on Canvas, but I promised someone that I would show it to you in class today as well. So there's something that other than like all these different approaches we've been talking about are really good ways at eliminating a lot of the bias that we've talked about. So instead of using instrumental variables, which we can poke holes in, right, aren't always perfect, even panel data, we're limited to what we can do with it. People will design these economic experiments to try to eliminate all of these different possible potential sources of bias. So we have a pretty good econ experimental cohort of professors here. So they run these experiments in computer labs. They kind of set up these games, these economic games, which they have people participate in. You get paid for participating in them. I don't know what the average rate is. I'm guessing to try to attract people at this point. I know that different experiments are different, but probably earning like essentially like $20 an hour, probably on average, if not a little bit more. So have any of you guys done these? Yeah, a couple of you. Is that about right? What you're seeing?
I think I walked away with like $17.
Yeah, I was gonna say, it depends on your performance in the game to incentivize you. Your payoff depends on how well you do in a lot of these games. So I would say it ranges anywhere from like 15 to 25. So you around 20, some are a little bit less, some are a little bit more. But they're basically collecting data so they can get unbiased estimates and they don't have to worry about a lot of these other things we talk about with real world data, right? So I just told the researchers I'd make you guys available or aware of this. You can use this QR code. I'll post an announcement. They're not just like running through the end of the semester. It'll be next semester as well. So, but if you are interested, you've got some extra time, you're feeling good with where you're on finals, maybe take a look and see what sessions are available. Okay. The only other thing that I have for us is this in-class quiz. So if you go on Canvas, open this up. And here, let me make sure I think I remember this correct. And now I'm just wanting to make sure before I'll tell you. Yeah, okay, it's 42.5. So all you have to do, it's on the main homepage of Canvas at the very bottom. These 2 questions aren't worth any points, but it helps me kind of direct next week. So what topics do you want to see more review of? So we've covered really 5 topics. Non-linearities, so this is like quadratic models, log, interaction terms, measurement error, some of the missing data issues. That was a little bit smaller of a section. Panel data, that was the video recordings I put up in place of the classes we didn't meet in person. And then this week's instrumental variables. So some of this older stuff, I never know, like what's easier to you guys, what's not. Maybe you want to go over more of the stuff that we haven't covered for a while as opposed to more recent. This is just a way of me to make sure that I'm using next class to be as efficient for you guys as possible. Right? I don't want to be going over things that you're not as a whole as interested in, or as in shouldn't say interested, as like concerned about going into the final. Also, just kind of what aspect do you find was, again, kind of similar to the quiz, just getting some feedback and the things that you found more difficult. And then today's magic number, this is how you get kind of all the points I can make sure that you were here in class today, 42.5. Okay. So 42.5 is the real thing that you're really interested in. It's making sure you get those 5 points for being here in class today. And then answering these will kind of help me direct not only next week, but also kind of future semesters for me. 42.5. Exactly. Yep. So once you get that submitted, you're free to go. So all you've got left, so like I said, that 6 quiz, which is just participation based, just get on, answer all the questions, get it submitted. And then that final 6 problem set. Other than that, start thinking about studying for that final exam. Okay? So I'll see you guys back in class on Tuesday. I won't have office hour, I will have office hours next week, Monday, Wednesday, typical 12:30 to 3:30. If you want to meet with me tomorrow, I should be available most of the day via Zoom. So if you do want to meet, send me an email, we can set up a time and a Zoom link. Otherwise, I'll be, like I said, available during my normal office hours next week on Monday and Wednesday. Okay? All right, have a fun, safe weekend, and we'll see you guys on Tuesday.